Well, hi, I'm Kathy.
Hey, I'm Naama.
Hi everyone, I'm Rachel.
Everyone, I'm Riana.
Girl power.
Great. Okay, so we're gonna start with the working demo video. Great. So here, yeah. So the program's running, and I'm sorry for the poor video quality. But after it runs, you can see that it detects blobs and creates a point map of the detected blobs. So here, I'll pause it here real quick. On the left, I think it's here. On the left here is what happens after we calibrate the camera to undistort the image, because that's important to try to get an accurate measurement of what's surrounding us. So then this is what happens after undistorting our two inputs. And then here is the color blobs. I mean the blobs of the objects, and then this is the 3D point map, point cloud, sorry, of what the program sees. Oops, let me put that. Yeah, of what the program sees after it finds all these blobs. Oh. Okay. But yeah, so this is what happens when we input images. But we also wanted to try to get this implemented on video as well.
So Kathy, before you go on, for the sake of our guests, also say what are you trying to do so they understand your objective for the project.
Sorry. So our objective was to try to find objects so our project is the machine system, the vision system of a yard cleaning robot. So essentially there are, if I bring the video back up, you can see that in this picture over here, there are little Lego bricks laying around in grass. So essentially what we tried to do is try to find these little toys, so then the robot can find them and pick them up. And that's the point of the 3D point cloud over here. It was to try to find was to try to locate where those objects were. So this was, again, the video was with 2 image inputs. But here is where we tried doing it with video input, and what we got so far was that it could detect key points within the video feed, and it would try to find the objects with blob detection in this screen over here. But yeah, that's as much as we got so far. So then we can start with the presentation.
All right, good morning, everyone. This is group number 2, and today we are going to introduce you to our group project, which is a yard cleaner robot. Next slide. All right, so the idea behind this project is to create object detection to help us clean up the yard. During this time of the year, the leaves are falling and there is not enough time for everyone to clean up the yard. So why not having a robot to clean it for us? Basically, the robot will identify the objects and specify whether they are natural or unnatural. So if they are natural, then it will keep it as what it is, but if they are not such as toys, kids toys, dog toys, etc., then it will create a 3D modeling to find a better way to pick them up. Next slide. Both of the object detection and 3D modeling was used to detect the objects in MATLAB. And next slide. All right, for camera calibration, MATLAB function used to find the parameters through calibration with checkerboard, and it's essential for finding the exact points in 3D and measurements of objects. Next slide. Starting with the object detection, as it's the computer visions that allows us to identify the objects in an image. So we use it to recognize the unnatural objects, which are the Legos in the grass. And the image on the right side is the one that we used for our code. And next, I will turn it over to Rachelle to finish up with the object detection.
Yep, so what is the process that we use to find the Legos in the pile of leaves? Looking at the flowchart, our group began by converting the original image to grayscale and binary. The color increases complexity of a model, so this is the first step and it was important for image processing. We continued by detecting the object using MATLAB's edge function, which finds the boundaries of an object by finding the discontinuities in brightness. In order to fill the boundary gaps, we use the Dilate function and use the Fill function to fill any gaps that were left in the image. At this point, there were still some leaves being detected on and around the Legos. So in order to remove the objects that were touching the borders of the Legos, we used the Clear Border MATLAB function. And we proceeded by smoothing the objects and checking properties like the area and perimeter. And with this information, we were able to create a condition that would exclude objects that were still being detected in the image, such as like small leaf specks that were showing. The final image that we processed can be seen on the next slide. So there are still some changes and improvements that we can make to the code to improve our object detection. We can work on getting a straighter border around the Legos, as well as getting rid of some of the leaves that can still be seen around the border areas of the Legos. Next, and now I'll pass it off to Riana.
Creating a 3D model of the objects the robot comes across would be very helpful in identifying toys and other miscellaneous items left outside to be picked up. A 3D model can only be created if the robot has at least 2 cameras operating at the same time. Next slide, please. Thanks. We decided that using a point cloud in MATLAB was the most sensible way to create a 3D model of our objects. A point cloud is a set of data points that represent coordinates of surface points on an object being tracked in real time. The process of creating a point cloud is shown in the flowchart here, where you first read the 2 images that the cameras are giving the robot, and then convert them into grayscale. A mask is then applied to the image to display a single blob per image. All of the pixels must be within the bounding area. The object must then be isolated from the first image, and then the key points can be found. Those same key points must be tracked on both the first and second images, and there must be at least 8 valid key points for the tracking to work. The camera matrix and the 3D points can then be computed, and a point cloud can be made. Thanks. Next slide. Thanks. Shown here on the right is the point cloud that we made in MATLAB with these images shown on the left. And then next to Kathy.
Okay, so now that you know a little bit about the project and its results, there are some further improvements that we would like to make if we had more time. The first way is to make a better way to try to figure out how to distinguish what is the objects we want to find in the point cloud. As you could see in here, it's a little hard to tell what this is. This is probably because all the points matched, because we put on all the points matched in the whole picture when we try to find points for the point cloud. And looking back, that's probably not the best way to do it. Because then again, it'll get like the points probably from like the grass or some other leaves in the background. And that leads to the next thing, where another improvement is to try to find a more robust way for the input images to be consistent, because again, the robot is going to be a yard cleaner, so the lighting outside will never be the same like twice, like each day. So trying to figure out like ways to have consistent lighting outside would be another improvement to our project. And then another improvement is to try to improve upon the object detection by, because the blob detection could only do so much. The blobs, as you can see, and as we've mentioned before, the blobs were, they could find the Lego bricks, but it could also find grass or leaves, and then trying to filter out which ones are actually toys and which ones actually the stuff in like outdoors, the natural stuff. We probably needed another algorithm or another probably like straight line detection on top of the block detection in order to differentiate between what were toys and what were not. But yeah, so the project was very useful in trying to like see how vision systems are implemented. One of the complications we went into was the image quality. So, and like the importance of our input images. When we first started the project, we had these two images. So this is one input image here on the left, and here's the other one on the right. And you can sort of see that here's a Lego brick, and so like this is a different picture than what's over here, and they are like very different angles. So so on the left there was the blob detection. So this was one blob that is found up here, and what we did was that we tried finding key points in here and then matching it to the second image on the right, and that was our first initial way to try to find objects, was to key point match within each blob and then try to make the point clouds of those. But that was hindered because of our two different images here. Yeah, and then again, with the blob detection, was that we couldn't consistently find just the Lego brick. We would always find like other things in the background as well. So like I mentioned before, we could probably fix this with having another algorithm like straight line detection. Like if there was a straight line here, then it would just choose that blob. And like up here, there's like a whole bunch of like weird lines, so it would filter that stuff out. And then sometimes when we ran our program with just the point cloud, or trying to find the point cloud, this is what our output would be. It was weird because like I would run our program multiple times, and sometimes it would be like what we showed at the very beginning of the presentation, where there's all these different points that was displayed in the point cloud. other times we get just this. And I think the reason being is because I would get this warning that in MATLAB that there would be that there's like a timeout, or sometimes there'd be like too much or not enough memory to like run it, which is I guess understandable because there's so much data that can be outputted through this program with the 3D points. So that's probably why we got outputs like this. And yeah, I'll just send it back to Riana to finish it up.
Some future projections of this technology would be to actually use this machine, kind of like an outdoor Roomba, where it can actually pick up leaves, sticks, and it also would have mechanisms to pick up dog toys, kids' toys, and other miscellaneous objects. You could also use this type of technology inside to pick up after kids' toys at a daycare center or a school. Next, please. Concluding the presentation, this machine vision could be used to help homeowners, daycare centers, schools, and businesses help keep their yards clean and tidy. And the next slide is just reference side, and any questions?
Good job, guys.
I
Yeah,
have a question about sensors. So it looks like you were just using either a phone or some off-the-shelf camera. Had you considered using something like a Kinect or something else that kind of already can understand the 3D world around it and kind of it already has an API to return a lot of that information for you, or were you constrained by having to use purely vision?
I think I didn't know that it Connect existed and that it would like help. It could help, but we also were constrained because of our situation right now. So we wanted to try to do something that each of us could do at home and that we already have the resources to. And for us, it was that was just using MATLAB and the input images. So we tried to do the best we could with what we had.
No, that's really insightful. Thank you.
I do have to mention here that in my previous machine vision, when we didn't have the pandemic and the groups actually worked together as groups and they had resources available in our lab, we have Connect and other stuff, other cameras available. But this was really hard because everybody is doing at their own home, whatever they have to come up with a demo. So I understand your point there. And if you had Catherine, if you had looked at Connect, it would have, your life would be so much easier to create the point clouds and detect in 3D because it has infrared. But I think you learned a whole lot actually trying to do this from scratch.
Really impressive.
Yeah, point clouds and all in MATLAB. So that's impressive, very impressive what you guys achieved in the 2 weeks and learned on your own, all that stuff. Yeah, other questions? One thing I have to say, I was really expecting a robot cleaning up the yard, but I guess it was too much for 2 weeks. Yes, other questions?
I got a question.
Go ahead.
It's kind of a twofold question. So what kind of robot are you envisioning? Is this like a vacuum type of robot? Is it one with arms that will pick up items? And then the second part is if the Legos or the dog toys are covered by leaves like they are at this time of year, how many sweeps is it going to do to detect that?
So I was kind of envisioning like a robot with almost like a wheel with like little grippies on it, and it would almost like grip and pull it into like some type of container underneath it. And in that case, it would probably try to get both the leaves and the dog toy, but it should be able to do both that way.
Or you can use a 2-stage, just blow the leaves and then see what's left and then pick it up. Yeah, sometimes, smart engineering helps also overcome vision problems. Yes, more questions. So I would mention that this what you're trying to do is differentiate between objects. So if you have leaves and you have Legos and you're not using color because you cannot depend on color to differentiate, or can you depend on shapes? Have you thought about how would you, so you're classifying into two categories here, objects which are natural like leaves and stuff, and objects which are, you call them unnatural. I call them very natural when you have little kids, Legos and stuff. And how would you differentiate between the two? What's a good way if you had all the time?
Probably like the best way would also use machine learning to try to like teach the system what like a leaf or like a broken leaf would look like, so that it would like, or it would also train the system to know what grass looks like, because that was a big problem too in the blob detection with detecting blobs of grass. So um, using a neural network would help a lot to try to detect either side, really, either the unnatural or natural side. I don't know which one it would want to learn first. So.
No, that's a good way. Neural nets may come in handy here to differentiate, because there is so much variety. But there's one really differentiating factor between what you call natural and unnatural, is that unnatural objects have straight lines and regular looking, while the natural looking leaves don't have that stuff. So you could be using, if you are going by rules and all, you could be using Hopf transforms to look for curves and lines. And if you have regular shapes, that's probably an unnatural object, versus a leaf which may not have those kind of shapes on it. So there are things to experiment. You guys really did good job. I like that you got 3D from 2D. So that's really cool. Doing the point cloud and all, there was a step up here to try out and experiment. All right. Any other questions from anyone? The classmates, you can ask questions too. Okay. Well, guys, great job.
Thank you.
Thank you.